My name is Brendan Bloomer. I'm a serial entrepreneur and venture capitalist. I've been involved in everything from virtual currencies inside of big online video games to real estate. A couple years ago, I got involved with the blockchain. I initially was on the private equity side of things and started looking around the industry for platforms that I thought had the ability to take, blockchain really mainstream enterprise. I found a very talented group of individuals that had been behind some of the largest smart businesses in the market today. And we've been working together on a project for the last 9 months. And I'm really excited to show you a little bit more about EOS. But without further ado, I'd like to introduce the CTO, Dan Larimer.
Thank you, Brendan. So today I'm going to introduce EOS but before I do that, I'd like to review a little bit where we've been. Bitcoin started back in 2008, proved the concept of the ledger. And since then, it's been, blockchain technology has been explored for more and more applications. Ethereum has been attempting to do general purpose smart contracts on the blockchain. But we believe that the future, everything is going to be on the blockchain. And it's going to require a whole new scale of performance. So what is high performance? These are the requirements of real industry. You have 20,000 transactions per second just to do a Visa and MasterCard, not to mention all the other payment systems out there. Facebook's 52,000 likes per second, not including all the posts and voting and other actions that the users take. And if you're in the financial industry and you're trying to do trading, it's 100,000 transactions per second per market pair sometimes. So imagine putting all of these on a single platform so they can interoperate. Well, that would require millions of transactions per second. This is massive scale. This is what industry actually requires. And this is what blockchain technology gives us today. There's a huge gap between what we can do and where we need to be. So I'm going to talk about how we get there. And I'm going to start by talking about my history of past 4 years of development in the blockchain space. Back in 2013, I introduced the concept of the blockchain as a decentralized autonomous company. Now it's been referred to as DAO, and that's been sort of the language that stuck, but it was first introduced by a blog post of mine back then. I set out to build BitShares, a decentralized exchange on a blockchain. At the time that I was doing this, the only blockchains out there were Bitcoin, clones, and Ripple. But I had vastly different requirements. Exchanges needed to be fast. Transactions could not be reordered. You needed finality very quickly. So very low latency, very high throughput. In order to achieve that, I invented delegated proof of stake. And that provided us fast confirmations. But I was still using technology and design approaches borrowed from Bitcoin. So in 2015, I had to reinvent the entire thing, re-implement it in order to get higher performance. So I borrowed technologies from the LMAX exchange, which processes millions of transactions in a single thread, and created graphene. It's been proven to do 100,000 transactions per second on a local machine. In a distributed environment, it's done 20,000 transactions per second. This is peer-to-peer around the internet, organized by people other than myself. So this is very proven technology. We also added other innovations there, including making it self-funding. And self-governing. So the blockchain can actually hire people to do work and make sure it continues to go on. So we also introduced account permissions. So BitShares, you don't have public keys and hashes that you're sending things to. You have account names, and you transfer currencies to and from each other by name, which makes it really easy to transact in. And it also has the most advanced permission system in terms of multi-sig. You actually sign the transactions on the blockchain. You can change your keys without impacting all the other parties that you're multi-sig to. You can say, I'm going to allow this other account to manage my account without having to assign keys to everything. So I encourage you to check out the dynamic hierarchical threshold multi-sig. Big long words, but there's a lot of properties there, because that was an innovation in BitShares. Then in 2016, we wanted to take blockchain mainstream, and that meant implementing social media on a blockchain. Social media has very different requirements, even more challenging requirements than an exchange. People expect to be able to vote, post, and comment for free. You need to have free transactions, no cost to sign up. You don't want to charge users to sign up, no KYC or any other barriers to entry, or people just leave your social media platform. It needs to be so easy to use that people don't even realize they're using a blockchain. And we achieved that with Steam. Steam is the first blockchain that has old ladies and kids using it. People who've never been into crypto get involved with Steam when they realize that they can earn cryptocurrency rewards worth thousands of dollars for posting makeup tutorials. In 2016, we conceived it in January, started work in February, launched the blockchain toward the end of March, launched the website on top of the blockchain in July, and 3 months later we were in the top 10,000 websites in the world. We've got 15,000 active users posting and voting every single day, 35,000 visitors every single day, unique visitors to steemit.com. And there's many other clone websites because Steem is just a block explorer of a public blockchain, public database. You have unsophisticated users who can't be expected to secure their computer and perfectly protect their private keys. So we have to make it resilient so that eventually when their keys are compromised, they can get their account back. Because it's not just losing money. They're also losing their identity, all their followers, and everything else. They need their account back, their name back, or they won't use the platform. And if you can do it for social media, but every other application, users have more or less the same expectations. So Steem introduced hacked account recovery. We use any old owner key combined with a second factor authentication, the person who created the account for you. You can get your account back. And that's been used many, many times to help many users when their accounts have been hacked. And we added security through locking up funds for a period of time so that when you're hacked, you have a chance to discover it and then recover before the funds are gone forever. The element of time is indispensable to security. When your Bitcoins are hacked, you don't know it until the money is gone and it's too late to do anything about it. Here, you get hacked, you get notified, hey, transfer card I didn't authorize. You go to your recovery partner, you get your account back. You never lost any money, you cancel the transaction. So this is what I've been doing for the past several years. I believe that Steem is the example of what decentralized applications need to look like, indistinguishable from centralized counterparts, and meeting the expectations of users. Unexpected fact is that Steem and BitShares are actually the most used blockchains in terms of transactions generated by actual users. This is the market share of Bitcoin, Ethereum, Steem, and BitShares in terms of actual transactions on the blockchain. Very few people realize this because these have been grassroots movements. Haven't had a lot of big finance behind it. But it really shows that we've tapped into something that people can use, people are transacting on it, and we're using a fraction of the capacity. Just less than 1% of the processing capacity of these networks are being used currently. So there's lots of room for them to scale. Now imagine putting all of them on a single blockchain, and you realize they get very crowded on some other platforms. So where are we today? Today we have the world computer and a bunch of people trying to build applications on top of it. But these app developers have a huge gap to cover because every application needs a whole bunch of services. They need an operating system that provides all the things that are in common between Steem and BitShares: the accounts, the recovery, the permission management, the database. So every app's trying to bridge this gap, and everyone's doing it slightly differently, which is confusing users. And it's a difficult task to do right. Furthermore, because everything's being implemented in the app layer, it's being done within relatively inefficient scripting environment, which means it's like running Windows Vista on a 286. It's just consuming too many resources, and there's no room left for your app because you run out of gas. What do decentralized applications require? Because we don't want the platform to get in the way of the application. We want the platform to be able to build Steem-like applications, which means they need to support a web application, so users don't have to download and install anything. You need to support millions of users. If you can't support millions of users, you can't build a business that's going to grow and recover your costs, or the cost per transaction will be so high that you won't be cost competitive with your centralized competitors. It needs to be free to use for your users. You don't want to charge micropayments every time someone loads your web page. You want to offer them freemium models or different monetization strategies. If you want to charge users for something, it should be the application's choice, not the platform it's running on. It needs to be responsive. When a user clicks submit on your web page, it needs to get feedback immediately, and it needs to be upgradable. No business plan, no application survives first contact with the market. You need to be able to upgrade to keep your business afloat, to adapt to changing market conditions, to add new features that users expect. And if you can't do that, then your application will stagnate and your users will leave. This is in addition to all the other things that you require: account names, not keys, no fancy cryptographic, thousands of actions per second, account recovery. But something that's often overlooked in this space is bug recovery. Software is an imperfect art. There's only one way to do it right and an infinite number of ways to screw it up. So you're guaranteed that statistically that there will be a bug sometime. And those bugs could be something that lost millions of dollars in the DAO, or other issues. So you constantly see cases where some flaw was overlooked by the program, or even, it doesn't matter how many eyes you have on it, doesn't matter how much formal verification you do, doesn't matter what language you use, there will be bugs somewhere in the stack that will have an impact on you. So bugs and upgradability kind of go hand in hand, but you need to be prepared for it. And if you're not prepared for it, then you're not having a realistic view of software development or business. EOS introduces the first blockchain operating system. It provides every application with its own private database with multiple sorted indices. It handles all the account permissions, account names, account recovery, so you don't have to worry about that. You can just think about what things you want your users to do and what permission level they require. It handles all the authentication, scheduling, and inter-application communication. And it does all this with parallel processing. So everyone's applications can run in parallel. And you can run nodes that only run the applications you need. You don't have to run everyone else's business just to run your own business, although the block producers do have to run everything. But block producers have the ability to distribute their workload over a cluster of machines if necessary, so they can scale horizontally. That's all made possible by asynchronous communication between the applications. And because all applications are designed with asynchronous communication from the start, it also means applications are designed to support communicating with other blockchains, which definitely has to be asynchronous in how you communicate. So not internal communication with local applications, as well as external communication with other copies of EOS or other blockchains that support a compatible protocol, which allows you to have private enterprise chains that can communicate with a public chain. So EOS is the first blockchain operating system that enables much faster application development, massively reducing costs. I want to bring you back to Steam, where we used the exact same design pattern, and we were able to build with 2 engineers an entire blockchain in C++ in just a few months. That same design pattern can be used here, except you don't have to implement all of this. In Steam, we had to implement all this stuff as well. So it should be much faster to develop your applications. I'm going to go a little bit deeper into how we make all this stuff happen. So I apologize for the less technically inclined here. But the goal is to support thousands of commercial scale decentralized applications by running them all in parallel, removing the CPU bottleneck. Single-threaded performance has not been going anywhere. Intel is spending billions of dollars every single year trying to eke out a few percent increase every year. Everything goes parallel, just how graphics cards work, the multiple cores. I already talked about asynchronous communication. Separation of authentication and action. When you build smart contracts, there's a whole bunch of computations you have to do to verify if someone's allowed to do something. You have to check, do they have sufficient balance? Do they have sufficient permissions? But after you've decided that they're allowed to do it, the actual action that you're doing is decrease this account, increase this account. We separate that logic into read-only steps, which can be run in parallel, whereas the write steps have to be run sequentially. And so that enables a lot of performance gains, a lot of parallelism and optimization opportunities. The other thing we do to support scalability is we publish the source code on the blockchain versus the compiled assembly. The source code is the human-readable stuff that we actually write. And when you publish the code, you can target any architecture. You can change the virtual machines. You can target Intel or ARM. And that gives huge flexibility for optimizing the performance long after you've published your app. It also means that we eliminate the concept of gas. Gas is where you have to count the exact number of instructions. You can change how you execute the program without changing its meaning. And the source code captures the intent of the users, whereas how you execute it's more of an implementation detail. We make it extremely flexible. We already have delegated proof of stake for electing the block producers, for making decisions for the network. And block producers on all blockchains have the ability to decide which transactions get included, which means they can censor transactions, which means they can freeze accounts. And this can be used to freeze broken accounts. So if something like the DAO happened, the account could be frozen until people could figure out what the proper software fix is. But instead of having to hard fork the entire network, the block producers have the power to collectively update a single contract, a single application, without impacting everyone else. It means you don't have to hard fork the network to fix a bug in one application. Now, ideally, applications have their own built-in governance system for deciding when to update the code. And this is used as a last resort when an application basically messes up their application so bad that they can't even fix it themselves. Or perhaps the application revoked the ability to update itself because it's been running perfectly for 2 years. No one expected to find a bug. So they revoked it so people can use it as an autonomous smart application. But we know nothing's perfect. Even with years of testing and use, people still find issues in proven code. For example, OpenSSL. The other way it's flexible is we can support multiple virtual machines because all communication between applications is through on-blockchain messages with well-defined formats. Virtual machines don't care what language or virtual machine the other applications are running in. So we're looking at using Ren and WebAssembly. These are very fast languages. Ren is almost as fast or faster than Lua and is easily sandboxed code. WebAssembly is a web standard that's got a lot of industry backers, and it can be made deterministic. So those are the things we're doing there. We can add other languages, and because we have governance and other systems in place, it's possible to expand in the future. We've talked about the elected block producers, but we also introduce a new concept. Think of it as a peer-to-peer terms of service agreement. We call it a constitution. The idea is that any two parties can sign a contract in counterparts. It's as if they signed the same contract. So all of the users are parties to a contract with each other. That contract will be legally binding, like any other contract. Every time you sign a transaction, you're also confirming the contract. And the governance process allows the community to update the terms of service as necessary. And what that means is that when a dispute does arise, because disputes happen, bugs happen, then there's a process and a jurisdiction already established. You don't have to worry about people bringing you to court in some foreign jurisdiction under some laws you've never heard of. And of course, we've got some funding here I'll get into a little bit of how the system's self-sustaining, like BitShares and Steam. The last thing we focused on is usability for the developer. We really believe that developers need to be empowered to adapt applications to the user's needs instead of adapting users to the needs of the limitations of the underlying platform. So eliminating fees is one of those things. If the platform requires fees, then you have to adapt users to pay fees. If it requires hashes and account names, you have to adapt the users to that. We believe that the software needs to be flexible enough so that users, you can think in terms of what does the user want to do, and then work backwards to making it happen. Everything is completely transparent. All the databases are defined by schema. So you can write a block explorer that will explore the state of everything in a human-readable way. All the messages passed between all the applications are also defined by schema. So everyone can read everything that's going between each other. And the permission system's declarative. I can say, I'm going to give your account permission to trade on this contract exchange. And I'm going to give this other account permission to post for my social media account. And keep them separated and well managed with multi-sig and organizations. So we have the generalization of the permissions architecture of Steam and BitShares and taking it to the next level. So let's talk about the EOS token. It's what everyone's most interested in. The EOS token is never consumed. There are no fees in EOS. Instead, when you hold the token and you put it in a staking contract, you get access to a percentage of the available resources proportional to the stake you have. So if you have 1% of the EOS, you can use 1% of the total storage capacity of the entire network. And when you use your storage, you can't get your EOS back until you release your storage. Likewise, you can consume the bandwidth and the computational resources of the network proportionally. If you'd like more information about how that works, it's very similar to how it works in Steam. users post and vote. They never have to worry about fees in anything they do on Steam. We've got the voting rights also tied to the token for electing the block producers, and also controlling how the 5% inflation or emission is allocated. This 5% is actually something that's covered in the Constitution, where everyone agrees in advance that it will not go above that rate, but it can go lower because you can control where it goes, including to a contract that destroys it. First of all, the token holders can pick 3 smart contracts, 3 accounts, or businesses to receive the emission proportional to approval voting. So just like you elect block producers, you elect the top 3, and they receive funding proportional to the number of votes they receive. Each of those smart contracts can either be a simple contract that destroys it. It can be a centrally administrated foundation, but perhaps what's most interesting is that it can be a decentralized application like Steam that potentially distributes funds to thousands of people every single day according to a collective budgeting, decentralized budgeting algorithm. So there's huge flexibility. Now, each and every year, Bitcoin and Ethereum are spending $3 billion to burn on electricity. We're just taking those potential resources and redirecting them to according to the community. Because there's some things that everyone benefits, but who should pay? If you own 1% of the network, should you pay to promote the network? You have to get 100x return on your investment just to break even on every expenditure if you only own 1% of the network, and most people own less. So it's very important to have a way for the community to pay for things that benefit everyone, and to do so in a decentralized, sustainable manner. You never have to worry about the blockchain running out of funding as long as it has some kind of market cap and people who are interested in promoting it. So I'm working with a great team. You met Brendan earlier, but there's a huge team behind all this with lots of industry experience. A lot of big players in the industry are working with us, including Lee and Bo and Brock Pierce. And we've got a lot of partners that are already involved, Bitfinex, Ubini, Blockchain Capital, and many others. So this is a big project with a lot of really quality people. And of course, we want to involve all of you in making EOS a great platform for everyone.
We spent a lot of time going around and speaking to VCs that are well positioned in the space. We got a lot of feedback before we wanted to present this to you. We've been working with Blockchain Capital. We've been working with Fen Bushi, Li Xiaolai, Bo Shen. And so we're really excited to bring this to you. We've done this, we've been spending a lot of time on it, and this is something that we want to be built through an iterative conversation with the community and the existing players so that we can put something forth that is in the best interest of everyone. Brock, you have anything you want to add?
For those of us that have been around a long time, I mean, this is exciting times. Very happy to be involved, both personally and through Blockchain Capital. This is the most exciting, I guess, upcoming offering in the space. Highly recommend you come back and listen to as many of these conversations, engage with some of the team to the extent possible. And we're throwing, we sponsored both the receptions yesterday as well as today, and we're throwing a big party. So come up and chat with one of us if you're looking to get an invite. A bunch of T-shirts here in the back. If you want to represent EOS, we love seeing that.
Hi, great presentation, thank you. You mentioned that there is no gas. So how does that work in comparison to, say, how
Sure.
Ethereum works?
So gas is the concept that you meter every calculation used. And when you have gas, you make it part of consensus, which means everyone has to agree on the amount of gas used, you dramatically reduce the flexibility of optimization. You limit it to a particular sequence of instructions that everyone must execute the same way, even if you could change it from a linked list to an array or something like that. So there's a difference between the meaning and that. So we have block producers. Block producers can use wall clock time, and if they decide to include the transaction, then obviously it completed, and they felt that it was executed in a reasonable amount of time. Another way you could view is all transactions, if it runs, it runs. If it doesn't, it doesn't. The block producers get to decide, and they can use any subjective measure they want. So there's virtual machines are sandboxed, and so periodically they check the clock to see if too much time has run off, and if so, they abort. And so there is limits on how long things can run, but the actual calculation of the number of instructions are not part of consensus. It's an implementation detail. Each block producer could do it differently. If one block producer runs it, the other one will run it, unless, of course, it goes into an infinite loop, in which case they'll dismiss it and reject the block as bad. But generally speaking, all the block producers are trusted, highly vetted public individuals who have financial incentive to include transactions, because they're paid to include transactions. And if they're not including people's legitimate, reasonable transactions, they'll get voted out, and new people will be voted in, and they'll lose their future income stream. So there's no need for users to pay the fees, because it's a community effort to cover the cost and make everything happen. So it really changes who pays.
Yeah, so in terms of that, then, have you guys simulated, potential attack vectors to? Obviously, there's going to be the delegated block voters, so they can turn things off. But in the meantime, before they figure out that people are attacking the network, is there any issues with like massive parallel attacks and things like that you could foresee, or is there something that prevents that from happening?
Well, there's several types of attacks. There's spam attacks, which are prevented by the rate limiting algorithms that we've already been discussing. And then there's attacks on the logic. Ideally, sensitive, valuable actions have time delays built into them. So there's a difference between when the attack is started and the user discovers it and they have a chance to respond. It's like the difference between the cash in your wallet and the cash in your bank account. If you lose your wallet, it's gone, but you don't keep too much there. But bank account, maybe you get text message and you can cancel it, maybe with extra protections. So the idea is hopefully contracts build in enough things that people can detect when things go wrong. But it's always possible for the community, and part of the goal of the terms of service is everyone sort of agreeing to work to help people actually respect property rights rather than code. Because code is an imperfect expression of the intention of the community. Of course, it's a much, much better, orders of magnitude better expression than the legal documents we have today, and it eliminates most disputes before they happen. But people can work together to build a new framework for handling property rights. So high-speed things, like if you steal someone's funds and you push it through an exchange, now you got too many counterparties to reverse it. Those types of things will still happen. But hopefully things like the DAO, which was a slow-speed attack, they had time delays. It could have been prevented. So introducing time as a security metric or component is actually critical in designing your applications. And NEOS makes it easier to introduce time delays.
Thank you. I just wanted to ask, the big differences between Ethereum and EOS, at least from what I gathered, was that in Ethereum, the instructions arrive at the same time across all the nodes, the VMs. If you're doing parallel processing, how do you ensure that they do arrive in that order? So, one node isn't like executing the instructions way ahead and the others are behind, and just potentially in terms of an attack.
All right. So every account is run in parallel. The block defines the schedule for how everything is run. So the block producer receives everything and might have a whole cluster of computers all run by the block producer. He might say these contracts are run on this node, these contracts are run on this node, and he'll schedule it and then aggregate it. And he basically says, here's a block. Everyone else can receive the block. They already know that everything can be run in parallel, so they execute it in parallel without any locks or any race conditions. So you don't have to worry about getting to one node instead of the other, because there's actually a defined order. And in fact, you could run the entire thing sequentially on a single thread if you wanted to. But the parallelism is provably parallel without conflict.
This is so cool. Seriously.
Thank you.
All right. Do you have any details on how the nodes or the block producers are incentivized in more detail, and how competition between them works, or if there's any at all?
Sure. All block producers are paid the same rate per block. The block producers actually vote amongst themselves for what their rate is, and it comes out of the 5% total. Anything that's not paid to the block producers is distributed elsewhere. Now, if the block producers all vote to pay themselves the entire 5%, the community might say, maybe we should vote for different people, and they get voted out. New ones who are willing to vote for more reasonable pay will. What that means is the block producers will get paid enough from the community to cover the cost of their data centers. We have a philosophy that you can have 21 different block producers. The top 20 are produced every minute, and then one extra wild card is selected proportional to total votes. So everyone has a chance to produce a block periodically, but the top 20 produce every single minute. And they get paid enough to have a data center with fiber optic cables and gigabit connections between each other and high availability, entire clusters. And the market feedback between competing for votes and providing service should balance it out and make sure that they have a profitable job, because they're also the ones that have to implement the governance and oversight and be responsive to issues that come up. So they're supposed to work together on behalf of the people who voted for them. So they're not in competition with each other, except for the fact that they're competing against the people who aren't in for a job. So there's always outside pressure, people who want the job. But once you have it, you're all on the same team, and you're all moving forward together to advance the platform. If you like more like real-world examples of how EOS works, study Steam, study BitShares. They're the earlier generations. So there's a lot of stuff published out there about how delegated proof of stake works, how free transactions work on Steam, how the permission system works. This is an incremental improvement, adds parallelism and generalization to stuff that's already been proven. And that's the difference in the approaches. We figured out how to build decentralized applications first, and then they're generalizing it, versus attempting to generalize something that hadn't even figured out how to build yet.
So what are the hardware specifications behind the data centers that are going to be the block producers? Like, are you guys going to have GPU farms that can handle, large computations?
Well, that's the thing that kind of grows with scale. So Steam and BitShares can operate on traditional Intel CPUs, 8 cores, whatnot. So these things will run on Amazon EC2 instances without a problem for the foreseeable future, handle all of Steam and BitShares and more on very simple nodes. By the time this thing scales, the technology will probably evolve. I don't know what the data center and clustering environments will look like, but it's something that can evolve over time without having to say you need it all at once. And the block producers will be incentivized to increase their capacity. So we expect that actually most application developers, this is actually what I should have said earlier, we have a very different philosophy on who should pay fees. Imagine if you're building a website and every time a visitor visited your website, they had to pay Amazon a micropayment to cover the hosting costs for you. That's how blockchain applications are built today. We believe the app developer should provide the resources, the server and everything, and then the users should be able to use it for free, and the app developer can figure out how to monetize it. So it's very much following a traditional model where the blockchain is just decentralized EC2 with smart contracts, and the business models are the same. What happens is when you own the tokens in the system, you own 1% of the resources. But everyone who is a token holder has financial incentive to vote for people who will add more. Now, initially, there's going to be so much capacity that people will delegate their allocation to you, and all applications are going to be free to use. Even no developer is going to have to worry about covering their own fees, because the people, they'll be lent the resources as long as they're not abusing it. And the power of that is, if someone does start abusing it, all right, fine, we'll take back the free stuff that we lent you, and you can buy your own, and then you'll get rate limited according to how much you actually buy. But that means huge opportunity. It will scale as necessary, and there's always incentive to figure out ways of scaling it more. So eventually people will figure out how to run it on a GPU and run it on clusters and things like that. So the idea is when we initially launch, it'll be single-threaded, but you could go to multi-threaded without a hard fork, because the data and the design is designed to be run in parallel.
As a developer, what would be the next steps of getting into like writing these types of contracts? You said it was similar to like LUA. Are there any resources available, and when do you expect
I've published a post. If you go to steemit.com/EOS, there's or eos.io. That'll link to all the Steemit resources. We posted an example of how the contracts could look. Some of this stuff is still under development. We'll be releasing our GitHub repo at the end of this week. But yes, visit our resources there. In terms of learning the language, you can look up ren.io is the language that we're using initially, because it's a very lightweight language, high speed, high performance, and something that was easy to sandbox. So that's where I would go to stay up to date on the latest stuff. And definitely sign up to our mailing list, which you can find at eos.io, so that you can stay up to date on the updates. But if you're a developer, definitely like to hear more from you about how we can make this the best platform, a platform that meets your needs. Because once we're going to have a long testnet period so that we can get the feedback and make sure that we can actually build the apps that we want to build on it before we lock it down.
Yeah, can you just provide additional color on the scale of the economics? I mean, you mentioned 1%, $3 billion. You do that kind of math, it's a little, for me, it just sounds expensive. But, exactly in terms, what does someone actually pay? And then is it variable? In other words, if your business shrinks, do all of these community participants suddenly have to pay more? How does that work?
That 3 billion number is actually just a reference towards what we're already paying for Bitcoin and Ethereum mining. So actually, if you divide up the amount we're paying over, it's actually closer to 3.5 billion now. It's moving on a daily basis. But if you divide it up amongst the number of transactions that these networks are actually performing, we're really paying somewhere between $1 to $5 per transaction. And that's where that number comes from. If you want to talk a little bit about how our method works.
So in our method, if you just rent your resources from other users, you can pay as you go, or you can own it, and then when you're done with it, you can sell it. So you're not locked in. It's just, hey, here's a computer. I own 1% of it or a fraction of a percent of it. It's got so much capacity that you can do everything, all the apps of Bitcoin, Ethereum, Steem, and BitShares using just a teeny tiny percentage of the resources. So when you create an abundance of capacity, costs fall down to zero, basically, and all applications are free. So if you are a developer and you don't have money to get the bandwidth requirements, but you have a legitimate app, there are lots of people that have money but no development that say, hey, I'll lend you my resources so that your app can go up, because apps add value to the tokens. The other thing is that you don't have a situation where the price goes up on the token and now the fees that everyone pays going up, because they're completely separate processes. Your token says the percentage of the resources is completely independent of price, which means that you don't have to worry about prices of all of a sudden market cap doubles, tokens twice as expensive, now fees just doubled for all your users, and you didn't account for it. So it's very good to have those two things be separate, and probably something we should emphasize. But I think people recognize when you have economies of scale, prices go down, supply and demand. And when you're limited by the scale, prices are so high that the applications that are viable, who's going to pay $5 per transaction unless it's a really big financial transaction, right? You're not going to do social media at $5 per vote, right? That just doesn't make sense. So scale is a critical component of bringing blockchain technology to the masses. And I actually believe every web application can be run on a blockchain and would benefit from running on a blockchain, because they're all fundamentally taking user inputs, modifying a database, and then displaying the result. And that's what a blockchain, that's the structure of EOS. So if you know how to build web applications, you'll know how to build on our platform. Thank you.
Thank you, guys. Really appreciate it. Good job, Dan.